Mojo!
This is the second Mojo moment on Osmosis, and it deals with some really confusing words and ideas like hypertonic, hypotonic and isotonic solutions. To understand and memorise what these mean, we're going to do three things. 1. Remember what diffusion is. 2. Remember that osmosis is just a special type of diffusion. 3. Remember what happens to a cell when it is in a hypertonic solution. Get those things memorised, and you'll see that you can work out the rest for yourself. You ready? Let's go. 1. Diffusion is the movement of particles from an area of high concentration to an area of low concentration. In the Mojo moment on diffusion, we describe a camper van that is so tightly packed that it's like a bomb that's ready to explode. So unloading the camper van is a bit like defusing a bomb. Defusing sounds like diffusion, doesn't it? Defusing a camper van is about moving the contents of the van from where they're tightly packed, or in a high concentration, to a place where they're more spread out, a lower concentration, like this. And that's exactly what diffusion is, the movement of particles from an area of high concentration to an area of low concentration. 2. Osmosis is a special type of diffusion where water moves across a partially permeable membrane from an area of high water concentration to an area of low water concentration. Now in our first Osmosis video, we talk about how new Australian cars, or Oz motors, are powered by water, not petrol. Oz motors reminds us of osmosis. And the solution to how water powers cars in Oz motors is that water is shy, easily embarrassed. So, if you concentrate on it and stare at it really hard, water gets embarrassed and moves from the area of high concentration to a place of lower concentration. Basically to a place where you're not staring at it. So osmosis is just a particular example of diffusion. In both osmosis and diffusion, particles or water move from high concentration to low concentration. The difference is that in osmosis, it is water that moves, and that the water moves through a membrane, a partially permeable membrane. Okay, let's pause for a moment. Just fill in the gaps below to check you have the first couple of bits sorted in your heads. Pause the video while you think of the answers. Here are the answers. Right, that leaves us with the last piece of the jigsaw. Hypotonic, hypertonic and isotonic solutions. How do we remember what all these are about? Well, the key is to remember just one of them. Hypotonic. Watch this. If a cell is surrounded by a hypotonic solution, water will move from the solution into the cell through the cell wall. When we see hypo in the word hypotonic, we think hippo. So imagine you're in a swimming pool which is made up of a solution of water, like, say, salty water. In the pool, there's one of those shark cages. It's like a cell surrounded by water. And then, a hippo jumps into the pool. What do? You get into that cell as fast as you can. Why wouldn't you? Guess what? That is exactly what happens when an animal cell is in a hypotonic solution. If a cell is surrounded by a hypotonic solution, water will move into the cell through the cell wall. So, osmosis is the movement of water from high concentration to low concentration. And in a hypertonic solution, osmosis makes water go into a cell. So therefore, that must mean that in a hypertonic solution, the concentration of water must be higher in the solution than it is in the cell. To remember what happens in a hypertonic solution, you just need to remember that it's the opposite of a hypo or hippo image that we just talked about. So in a hypertonic solution, water leaves the cell. An isotonic? Iso means the same, like an isosceles triangle has two sides the same length. So in an isotonic solution, the concentration of water is the same in the cell and in the solution. Guess what? Overall, in an isotonic solution, water does not move into or out of the cell. And that's it for this topic. The quiz and worksheet will make all the difference to you, so do them now. Make sure you redo all this when we send you the reminder, but in the meantime, thanks for using your imagination.